signed up for my AP test and on college board, it still says not registered, so I'm like, this is cool. So I'm just gonna make that run for it. She was like, oh, the site you use doesn't manually put it in the college board, so I have to manually do it myself. Like, I don't think the site is more than 40. So I was like freaking out. My dad like melted and I just spent $600 on his credit card and it didn't say registered. He was yelling at me.
State final.
Yeah, we were so. It was.
Yeah.
That's not there. I know. That's so hard whenever. Yeah.
That's really
I know. So there's, and next year, especially close, like even like, because last year, like everyone had to shoot like their best scores.
Sure.
But this year, like we kind of had to shoot.
Oh, you didn't do
It was a rough day.
That's not too far.
It was actually snowing and everything.
Oh my gosh, it's all around. Yep, perfect. Good morning, ladies and gentlemen. Okay, a couple things before we go in and dig in. So what I chose to do regarding the multiple choice of our Unit 5 exam. So if anybody has a concern about this, just let me know. If anyone wants to change your individual situation, just let me know. So remember, I had asked you, do we want the multiple choice to be worth 2 points apiece, which they usually are, then it would be out of 56, or 3 points apiece. And then I think what, 84, if I'm not mistaken. So what I decided to do, because not all of us, was this better? Or we're kind of split 50-50. So when you look into Power School, you will see that there's 2 columns. So, and I put it in just to make sure, and I have some more grades to enter. But if this, your score out of 56 delivered a greater improvement, then you'll see your score here, and then it'll have like exempt. I forget what it shows there, but like a dash. However, if it was better for you here, the exempt will be here, and then, yeah. So again, if you have a question on that, just let me know, and that won't matter. So this isn't even then included in your tally. Okay, so you get to start enjoying tomorrow, a 4-day break from school. I will be adding in grades and so on. So if you believe that you have a question for me or anything else, just send me an email. We are being asked as teachers to have it by 4 p.m. Friday, pretty much set, but I believe it's not until Monday afternoon that it gets solidified. Meaning down the road, they press a certain button and then we have to fill out all this paperwork if anything needs to be changed, but we can fill out the paperwork, so, okay. Concerns? All right, we are going to kind of alternate how we're going to approach today's class. So we have covered all of our content, and I've been showing us this. These are just circled because these were the last issues. Just to bring to our attention, at the very end of your packet, I would only ever share a summary or another resource that I think is worthwhile, if it's worthwhile. So if you feel like you need, because I understand some units seem a little disjointed, but I hope we understand it's this common theme of how do we measure really how exothermic or endothermic a process is. Okay, so I found some good resources that I hope I've laid out for you, just a review. So if you'd want, instead of just, by topic, here's a good summary. So could you please make sure you have your unit packet? Can we also get out the goldenrod packet and the green packet that I've given us? All right, we will get to the green packet in a bit. So the first I'd like to take a look at is the goldenrod packet, page 7. As we're finding our way, are there any questions that I can address? Any unit assignment questions, class problem questions? All right. This enthalpy of formation is just something that we just need to know. Not just apply, but need to know. So could we take a minute and satisfy question 12? Question 12. Dig in. Ellen, do you mind sharing? So what kind of directed you? So we'll get more time. I just want to give us some guidance.
The number of elements in the compound.
So if we simply really take the lead of the directions, yeah, now really we don't need all these words, because if they asked for the equation that would represent the enthalpy of formation, we are making 1 mole of our compounds from the elements in their standard state. So do you mind, sir? What do we have for? Is it okay? I'm just gonna, no coefficients yet.
Okay.
Thanks. So not diatomic, not diatomic, diatomic. Now, standard states, reference form, that would be where the enthalpies of formation of these are 0. Does sodium exist in allotropic forms? Remember, we talked about that we need to know 3 elements can exist in more than one form at standard state conditions. Remember, carbon can be graphite, diamond, or soot, but usually we're just being asked about graphite or diamond. Oxygen can be O2 or O3, but we know O2 is the way to go. But then what was the phosphorus? And we didn't talk about that one. So how do we know? Well, we go to that handy dandy appendix. So alphabetically, and then we see which form is 0. So again, not diatomic. Okay, that's not in question. We already know the ones that are diatomic, but it's the form, which is white phosphorus. So solid state, and you could do a comma or you could do another set of parentheses, white. Okay, and then we know sodium, right? We only have one metal element that's going to be in the liquid state. Oxygen, of course, gaseous. So we make sure that we have the lowest enthalpy forms, and then we take care of balancing. So Alan, take it away, sir. Okay, questions at all? And so when you would do this in lab and then measure the heat, probably we would do calorimetry. And as long as we're not changing pressure, this is that value. As long as we are, respecting the ratio and starting with these ingredients in their standard state at or reference form at standard state conditions. Good. Ellen, thank you so much. Do you need a minute for B? They can be in any order. I just respected the order that they're in your product. Doesn't have to be. We know nitrogen diatomic, non-allotrope, gaseous. Hydrogen diatomic. Good. And that's our form of oxygen. Yes.
So we'll have the allotropes memorized, but for the other elements, will we have the list provided?
Absolutely. Either the list or it'll be provided for you within the problem. Promise. So yeah, this one, I knew we needed to go to the appendix, but not sure. Oh, that gives specific heats. Oh, so yeah, if you need them, you'll be given them within the problem. Now, the only thing we might for a moment think, Mrs. Gerhardt, miss giving us that is if it is an element in its reference form at standard state. So if this said gaseous O2, we need to know that 0. Yeah, so we need to know that graphite would be the lowest enthalpy form, O2, and then phosphorus white. And then that whenever we're given these, that the values are 0. Questions for me? Reagan, did that satisfy what you needed? Yeah. Okay, so we know which way to go to satisfy the question based upon usually what we're given. So we're not going to solve this now, but like number 11, they give an overall reaction and then other reactions and their enthalpy values. So then we know, oh, Hess's law. And so we have to manipulate those. Yeah. If we're given enthalpies of formation, then we know we do the summation. If we would be given a question that asks about, breaking bonds and forming bonds, well, then you'll be given bond energies, and we'll do an example of that. Okay. All right. Let's see. What are we feeling? Dylan, make the call for us. Couple model choice, or go ahead and do like some brainstorming for the lab activity we're going to do Monday. Which should come first? All right. So in your lab teams, I'm going to ask, I'll just give it to one of the lab members, if you don't mind. The goal of Monday's exercise is to experimentally determine the enthalpy of the reaction of magnesium in the solid state. Okay. Actually, I should write it like this. We're going to be reacting solid magnesium with hydrochloric acid and single replacement. What should we get? Go.
Magnesium chloride.
And I know this isn't one of the always solubility rules, but this is soluble. And then we need 2 here. We're doing this reaction. So what I want to know, gosh, is that going to blind us almost, is what is the enthalpy of the reaction? All right. Can I put that floating 0 here? Are we at 25 Celsius? Pretty much. I won't ask you to measure it. We're close enough. Are we about 1 atmosphere of pressure? Close enough. What is the other condition? Go, Aaron. And we'll have a 1 molar solution to start with. Okay, so what I want us, yes. I gave 1 to every lab team. Yeah. Oh, is that okay?
Yeah, that's fine.
All right. Yeah, so I'm going to leave this up there. I just have 1 with every lab team. Sorry. I do have a couple extra if you feel like you would like. Sure. There's a couple more. Or you could definitely take mine if you would like. Now, what unit is expected, Colby, on enthalpy of reaction? Okay. Oh, joule degrees Celsius. I'm thinking, no, you're on the right unit. Praise God. So not that you ever would not be. So no, like it could be like, I don't know. You could have told me cupcake or something, and that would have not been close. Specific heat, joule per gram degree Celsius. Okay, that's specific heat. I want to know the enthalpy of the reaction. Flames, 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 heat, 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 heat. Yes, you do. Ask your neighbor. Yeah, usually enthalpies, like if you look at that appendix, all of the enthalpies of reaction are given in kilojoules. Now, it could just be kilojoules, but sometimes we'll see per mole reaction. Yeah. So this is the end value that we're trying for. So I want to know from you. We're doing calorimetry. So we know what we relate to that. Okay, so to find this, what measurements will you need? Measurements. And what equipment will we need? Okay, let's take 3 minutes to brainstorm. Okay. We have to make sure that we're not taking a leap when we're asked for a measurement. Okay, so a similar question was asked a handful of years ago on the AP Chem exam. This was part of a question that I was assigned. And I cannot tell you how many students wrote, we need the delta T. Do you measure delta T? No. What do you measure? Yeah. So initial temperature of the system. So I would advise, starting with the HCl in the cup. So do you have it in the cup? You add the magnesium because that's the system, right? And then you take the temperature when it's first added. Magnesium, alkaline earth metal. Now, not as reactive as alkali, but reactive. As soon as these come into contact, the reaction starts. And the temperature probe, it takes about 30 seconds to equilibrate, usually. So should we wait until we combine these to get the initial temperature? They're going to be sitting out. I'm going to set it out everything on Friday. So it will be sitting out in the room all weekend long and ready for us on Monday. So we can trust this will be the same temperature as that solution. Yeah. So we need the initial temperature of the solution, if we just call it that. Yeah. And then we'll need the final temperature. And we're okay to call it solution or system. Okay. What else do we need? As soon as you saw calorimetry, what came to mind? Hot dog, yes. As long as we don't change the pressure, this will be, right? Okay. So we figured out, then you'll subtract. So this is actually calculated, not measured, right? We'll use that to get this. So we got that. Specific heat, again, what I just addressed, that's not measured. We'll just know it. And the majority is water. So we take the specific heat of water. All right. So we need M. What will that be? Of course, mass. Mass of what? Go. How are we going to measure that?
So you're going to mass the magnesium and then mass the solution.
You got it. So we wouldn't say, mass of reactant because we need to measure them separate and then add them. Anything else we need? That's it. That's it. Those are the measurements. So what equipment? So a calorimeter and truly double styrofoam cup. I will give us amounts that are good and will give us good data. So like what is the minimal mass of magnesium we should have? A good volume. So I've done it a couple times and we want sufficient enough quantities that we'll get a decent temperature change. Okay, so we need the calorimeter and we're just going to use styrofoam cups. What else do we need? Tell you what, let's use a temperature probe. If that's okay with you, and thermometer, fine, because we can stir with a temperature probe. Do we need to stir? Why? So if you're taking the temperature in your styrofoam cup and you add the magnesium and the reaction is happening here, well, here is where energy is released or absorbed. If this is kind of up here, we want a complete agitated system so that the heat distributes and then we get an accurate temperature. So you could stir with your temperature probe, or could we put a magnet in there and set it on the magnetic stir and let the magnetic stir do it? We sure could. The magnet is surrounded by plastic. Plastic isn't a good absorber or giver of heat. So That, I mean, ideally it'd be made out of styrofoam, but we're good with that. Of course, balance, grad cylinder, or pipette, you'll be able to choose, or volumetric pipette to measure the acid. Anything else? So on Monday, no need to prep lab notebooks. I have a suggested, you don't have to, but I just shared an image of a suggested setup. AP students, not expecting us to remember from honors, but we use temperature probes in honors, and we would connect it to our calculators, and you had to use special calculators that had a program on it, DataMate. But AP students get lab quests. So I think in physics, lab quests. This is like a mini little computer all in one. This graphs for us, it collects our data, we can manipulate the data, it'll record events if we want with time. Oh, this is just fantastic. Fantastic. Okay, so everything that you need will be set out for you. We've talked about, you know, the relative approach. Here are the amounts that we're going to add. We're going to just trust that the solution is 1 gram per mil and apply specific heat of water. And then what you will do, run 2 trials. So in one period, there'll be no problem to run 2 trials. So at the end of our lab time, I have a green one. Your lab group, unless you'd like to turn it in individually, your lab group will turn in this final data table with supportive work on Monday. Okay, so on Monday, we'll take one of our periods to have a hands-on experience with calorimetry. Okay, questions for me? So no prep. We've already done kind of the talking prep. Everything will be out for you. We'll just need goggles and then go to town. Comments, questions, concerns. I'm going to ask for your, or how about if somebody in the lab group could just hang on to your brainstorming and then you'll just submit that. I just want to see your initial ideas. Whatever you did, you don't have to do any more of that. I'll collect this from you when you turn in your data table. Okay. All right. So to the green packets. All right. Second page, please. All right. So sadly, 6 minutes left. Could I ask us in these 6 minutes to do 3 multiple choice questions? Could we do number 1, number 2, and 3? And I'll provide the answer to 4 if you have time for 4. I want to do 4 on your own. All right, so dig in and I'll just walk around to see whatever questions we have. And then of course, share our answers. Could I rudely interrupt for a moment? I am very, very guilty of skipping over given information and going right to a question. We need to force ourselves. So I see, okay, I get all this information before question 1. All right, Gerhard, make sure that you look at what you're given. So I'm given a reaction. Oh, that's combustion. Oh yeah, I'm given the enthalpy of the reaction. It should be exothermic. All right, then it's telling me about the reaction, da, 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 da. Oh, I'm given enthalpies of formation. Oh, wait. Oh, it's giving me 2 waters. Oh, I need to be careful because my reaction only involves the liquid. So if I need, they're trying to see if I know which one I'm going to have to choose and use. All right, then, wait, this is asking for the standard heat of formation of CH4. Ah, so we have our reaction and they give us the enthalpy change of the entire reaction. So, right? One way we can find the enthalpy of the reaction is summing up our enthalpies of formation. Well, we know this. So, do I know the enthalpy of formation of everything but my methane? So I have my water liquid, I have CO2 gas, and I know that oxygen in the gaseous state is a big old 0. So we just will solve applying our coefficients. So we know the enthalpy of formation of CO2. We know water liquid times 2 minus, remember it's product minus reactant, 1 mole of methane. And then we're solving for this. So just algebraically. Okay. Now, 50% of the time, this is going to be a coefficient other than 1. So we just have to keep cognizant of that too. It's asking for the enthalpy of formation, which we know is per mole. The reaction just involves 1 mole. If it were 2, we just have to make sure we account for that in our algebra. Yeah, and our answer for 1 is B. Okay, our answer for 2 is A. 3 is D. Creative way to have us do Hess's law. And I'll just share, number 4 is B. And on yours, I've given an indication of bonds. All right, so my suggestion over this great 4-day break, relax, take naps, enjoy. Hopefully the weather will be nice. But if you want to, a little pocket of time for unit assignment, little pocket of time for unit assignment. Absolutely.